In this question, we are talking about the normal to the curve, and the equation of curve is y equals to 1 plus tan 3x. At a point P, where the x-coordinate of the point is pi over 12, meet the x-axis at Q. So the line x equals to pi by 12 meets the x-axis at point R. Find the area of a triangle PQR. So in order to do that, so the first thing that we should do is we need to find the equation of normal here. So let's find the equation of normal first. So equation of normal, in order to find it, so we need to find out first of all what is the gradient of normal. So gradient of normal at a point would be equals to negative 1 over dy by dx at that particular point. So in that case, at point P, so we need to find out what is dy by dx. So we know that y is equals to 1 plus tan 3x. So in that case, if I differentiate this, so dy by dx would be equals to differentiation of 1 would be 0 plus differentiation of tan of something would be secant square of 3x, secant square of same thing. And of course, we need to apply a chain rule. So differentiation of this inner function has to be just 3. So dy by dx would be secant square 3x plus 3. Now we need to figure out what is the value of dy by dx at point P. So at point P, the x-coordinate is pi by 12. So if I substitute it, so my dy by dx would be equals to, so it's secant square. So I can also write it as 3 in the front, the 3 into secant square. I can also write it as 1 over cos square, 3 times pi by 12. So that's basically 3 ones are 3 fours are, and 3 divided by cos of pi by 4 whole square. Cos pi by 4 is 1 over root 2. So in that case, this is going to be 3 over 1 over root 2 whole square. And this is just going to give us 3 over half, which is 6. The value of dy by dx is 6. Now, we need to find the equation of normal. So in order to find the equation of normal, so we need the y coordinate. So when x is pi by 12, what is the y coordinate? So that's what we need to figure out. When x is pi by 12, so if I need to find the y coordinate, I can substitute it in this equation. So that's going to be y equals to 1 plus tan of 3 times pi by 12. So that's basically tan of pi by 4. Tan pi by 4 is 1. So that's why it's going to be 1 plus 1 is 2. So now we know this. The equation of normal will have the gradient as minus 1 over dy by dx, and the value of dy by dx we have is that 6. And passing through the point pi by 12, comma 2. And whenever I need to find the equation of a line with a gradient and passing through the point that's given, so we use the formula of y minus y1 is equals to m into x minus x1. So using this formula, so if I substitute this information here, so it's going to be y minus 2 is equals to minus 1 over 6 into x minus pi by 12. And this is what is the equation of normal. So if you want, you can further simplify that. Otherwise, keeping it like this is also completely fine. Now we need to find the area of this triangle. Now we are talking about point P and point Q and point R. We know this point P is nothing but somewhere like pi by 12, comma. So let's say if this point is pi by 12, so pi by 12, comma 2. So that is where the point P is. So this is where the point P would be approximately. And Q is nothing but that the tangent line meets the x-axis. So whenever I talk about tangent line meets the x-axis, that's basically the x-intercept. So Q is the x-intercept. The x-intercept means we can substitute y as 0 and find the possible values of x. So that's going to be, when I put y as 0, so I'll be getting minus 2 is equals to minus 1 over 6 into x minus pi by 12. And 2 goes to the other side, and negative 1 also goes to the other side. So it will become positive 12 is equals to x minus pi by 12. So in that case, x would be equals to 12 plus pi by 12. So that means q would be somewhere here on the x-axis, and the distance between them would be 12. And we know this, the line x equals to pi by 12 meets the x-axis at point R. So if I talk about the line x equals to pi by 12, so that's basically this line. So this line meets the x-axis, means this particular point. So this point is what we call it as R. And now we have a triangle here. And the triangle looks something like this. And we need to find the area of this triangle. And we know this is 2. So that's why the area of this triangle should be half into base into height. So half into the base is nothing but r to q, which is 12, and the height is 2. So when I simplify this, I'll just get 12 units, and this is the right answer for this sum. So the marks distribution for this sum, and it's 8 marks in total. So it goes something like this. So getting the differentiation correct, basically this step. So this is going to give you 2 marker, and getting the x and y coordinate correct. So the point P, the finding out the particular y coordinate. So this is going to give us 1 more mark. And getting the derivative correct, which is basically at pi by 12, getting the 6 correct. So that's going to give us another mark. And getting the gradient correct. So because the gradient of a normal has to be negative 1 over dy by dx. So getting this gradient correct, so we'll have 1 more mark. And getting the equation of normal. So this is also 1 more mark. And figuring out what is the triangle would look like, and getting the final answer for area of triangle. So basically, this is going to give us 2 markers in total. And basically, figuring out this point would carry 1 mark. And this is how the distribution of the sum would go like.